Good morning, class. Good morning, sir. Mabuhay. Thank you. Please take your seat. Hey, Mark. Isn't mathematics is our subject at this time, right? Yes, 7 a.m. to 8 a.m. is mathematics, and Miss Christine is our teacher. Why is at the back? What is the problem? I'm sorry. Okay, I know that most of you are thinking that why I am here, right? Miss Christine is not around because she has an important matter to do. She is one of the members who prepared for the upcoming school activities. Okay, let's start our lesson. If you have your book, please open page 60. Chapter 4, Data Management. You can read? Me, sir? Okay, Mark, go ahead. Data management is used in business and education, whereas also called statistics. Data management is a science of collecting, organizing, presenting, analyzing, and interpreting numerical data. It refers to the mere tabulation of numeric information. It reports stock, market transaction, or to the body of techniques used in processing or analyzing data. Okay, thank you, Mark. Data management involves sampling methods that covers how data will be collected. Data management has different types: descriptive statistics and inferential statistics. The characteristic that is being studied is called variables. A variable refers to a property that can take of different values and categories. There are three common types of variables: independent variables or variable X, dependent variables or variable Y, and lastly, control variables or variable Z. Those are the three common types of variables that can be classified as qualitative variable and quantitative variables.
Measures of variation. So what is measures of variation? So measures of variations describe the width of the distributions. They define how spread out the values are in a data set. They are also referred to as measures of their dispersion and spread. Also, measures of variations can help convey meaningful information about sets of data because variability can provide a lot of information about data. It is important to know the different measures of variations. Learning about the measures of variations help you understand how to use this data. Measures of variations in statistics are ways to describe the distributions or distributions of your data. So there are four measures of variation. So first is wage, second is interquartile or IQR, and the third one is variance, and the fourth one is standard deviation. So that's all, and God bless.
Good morning, class. Now, let's talk about Z-score. But before that, who of you can give what the Z-score is? Ma'am, yes, Trisha. The Z-score is a measure of relative standing. It represents the distance between a given measurement X and the mean expressed in standard deviations. It locates X within sample or within a population. Well said. Thank you for that. So Z-score, it describes the position of a row score in terms of its distance from the mean when measured in standard deviation units. So let's proceed to the formula of Z-score. The formula for solving Z-score is Z equals X minus mu over sigma for population data, and Z equals X minus X bar over S for sample data, where X is the given measurement, U the population mean, sigma the population standard deviation, X bar the sample mean, S the sample standard deviation, and Z is the Z-score.
Good morning, class.
Good morning, Miss A.
Okay, sit down, everyone.
Thank you, Miss.
For today's discussion, I am going to discuss with you the lesson about the box in a whisker plot. Now, from your experience as a math student, I'm sure that you've come across different methods of visually representing data like pie chart, bar graph, and scatter plot, are a few examples of these tools. And box and whisker plots are another method of visualizing data. So now, who can give me any idea of what a box and whisker plot is? Anyone?
A, Athena wants to answer.
Christine, why did you do that?
Because I can. You're a devil. Yes, Athena. Miss A, box and whisker plot is just a tool that's going to help us to analyze data. Thank you, Miss A. Thank you for that, Athena. So yeah, box and a whisker plot is defined as a graphical method of displaying variation in a set of data. In most cases, histogram analysis provides a sufficient display, but a box in a whisker plot can provide additional detail while allowing multiple set of data to be displayed in a one graph. Like for example, in this situation. So for example, Christine owns a coffee shop and just keeping the data on the number of espresso that she made per day, the first step is to rearrange the values in order from least to greatest. So now we're ready to get the information that we need. So we'll start with the extremes. The upper extremes at 96, the lower extremes at 32. Now, for the median again, moving outside in to find the middle value, we have two numbers, 51 and 59. So we just have to add them up and divide that sum by 2. So 110 divided by 2 is equal 55, which is the median for this example. Now, notice that the median is between 51 and 59. So when we split the numbers up, we have to draw a line between those two values. So now to find the upper quartile, we find the median of those upper values, that's 65. And to find the lower value quartile, we do the same thing. For the lower values in this case is 44. So now we have all the information that we need. We can construct our box whisker plot. As always, the first step is to construct a number line that fits on our data. With the points that are upper and lower quartile at 65 and 44, and now construct a point for median at 55, and we'll use these points to construct our box. And now the vertical line through the quartiles, construct our rectangle, and then draw another vertical line through the median. Then we're going to plot points at the two extremes, that at 32 the lower extreme and 96 the upper extreme, and just construct your horizontal line, and the box whisker plot is complete. And now you're ready to visually analyze your data. So that's for today's lesson. Bye class.
Bye, Miss A.
Bye, Miss A.
Hey, Mom is coming. Okay, class, can you please settle down and prepare yourselves and especially your notebook? Okay. Good morning, everyone. Good morning, Mom. Okay, so you can take your seat now. Okay, do you have any idea about the probability and normal distribution? Anyone? Okay, Miss Reyes, so go, the floor is yours. Based on my research, ma'am, the normal distribution was also known as the Gaussian distribution. It is the most important probability distribution in statistics for independent random variables. So, most people recognize its familiar bell-shaped curve in statistical reports. That's all, ma'am. Okay, let's give her a round of applause. Okay, that's a good idea, Miss Reyes. So, to explain further about what Miss Reyes says, so the normal distribution is a continuous probability that is symmetrical around its mean. So, when we say symmetrical, it is the having similarity in shape, size, and relative position of corresponding parts. So, when we also say mean in statistics, the mean is one of the measures of central tendency apart from the mode and median. Mean is nothing but the average of the given set of values. So, most of the observations cluster around the central peak, and the probabilities for values further away from the mean taper off equally in both directions. So, I have here the example of normally distributed data height. So, height data are normally distributed. The distribution in this example fits real idea that I collected from 14-year-old girls during a study. So as you can see, the distribution of heights follows the typical curved bell pattern for all normal distribution. Most girls are close to the average of 1.512 meters. Small difference between an individual's height and the mean occur more frequently than substantial deviation from the mean. So the standard deviation is 0.0741 meter, which indicates the typical distance that individual girls tend to fall from the mean height. Okay, so that would be all. Thank you for being attentive. Thank you for listening. Thank you for cooperating. So, see you tomorrow. Bye, class.
Hello class, today we will tackle about correlation and linear regression. But in order to understand these two concepts, let us define them. First, a correlation? A correlation analysis provides information on the strength and direction of the linear relationship between two variables. Let us say the x and y variables. So, who can give me an example for this?
Sir, let's say for example, considering that we have the vertical line measures the weight and the horizontal line that measures height. As we can see, as the measure of height increases, the measure of weight as well is increasing. And we can call this as high positive correlation. So we can solve this by using this formula. Okay, that is great, John. Now let's move on to linear regression. Simple linear regression analysis estimates parameters in linear equation that can be used to predict values of one variable based on the other. Linear regression application in real life. Just for example, medical researchers often use linear regression to understand the relationship between drug dosage and blood pressure of patients. For example, researchers might administer various doses for a certain drug to patients and observe how their blood pressure responds. That's the example. So how important these two concepts? Anyone? Sir, may I? Sir, the importance of these two concepts are: the regression is primarily used to build models or equation to predict a key response, y, from a set of predictor x variables. Correlation is primarily used to quickly and concisely summarize the direction and the strength of the relationship between a set of two or more numeric variables. Thank you so much, sir.